You know, I've been sitting around this, week 2 of our online learning, and I've been making these videos for algebra because they asked for a couple of students, say, hey, we need a little help with this. And then last week, at the very end of the week, one of your pre-algebra students, one of your fellow students called and said, hey, Mr. Jerkins, I don't get this stuff. I need a little help. So I had an idea. Let's make some pre-algebra videos. So starting this week, every day, we're going to have a nice little pre-algebra video. But before we get started, just kind of like with the other videos I'm making, have a little fun. I went by school. I got my flag. Go Gators. Let's go. Rep it up. Fly away. Other things. I need something to do. I'm getting bored. I'm sure you are too. So I found some of these little grab bag, random bags. Let's see what we get. It's a Pixar bag clip. Oh yeah, we got Squirt from Finding Nemo. Rockin' Dude, Tubular. Let's go. You can go sit up here with other random things of mine that I've found. Of course, a day of mine would not be complete without a quote of the day. We'll do a little backtrack. We've been out of school for a while, so you've missed several of these. Previous one. It takes 3 days for me to wake up in the morning. Yeah, it does. Today's quote, I think, is actually very apropos. Don't underestimate the extreme measures I will take to escape this conversation. Just kidding, not really. But yeah, sort of, sometimes. We'll set that up there. Also, y'all know me, loving my Disney life. I brought some Disney pins with me, because why not? Got Nightmare Before Christmas, little Mickey Mouse head, all sewn up together, I think. And a little Donald Duck right here, the OG, the original, well, with the OG original. So, got a little Disney pen, all this stuff. Let's do a little Pythagorean Theorem. Okay, Ric Flair, Xavier Woods, and Kofi Kingston, pay attention. This is going to be on the test. And we're back, ready to talk about Pythagorean Theorem, right triangles. What we know about right triangles is that we can add up the squares of the sum of the legs. Here we have a leg, and right here we have a leg. If I add up the squares of both of those lengths, it will be equal to the square of the hypotenuse. Or, as we know, a squared plus b squared equals c squared. Now, you should remember this, hopefully, fingers crossed, from before spring break, because this is where we finished up right before we let out for that nice little 1 week that's turned into like a forever holiday. So, we're going to use this, prove it real quick, and then we'll look at finding some, or confirming it in just a second. Again, so using this wonderful formula, I know if I've got a right triangle like this with side lengths of 5, 12, and 13, that this will be a right triangle if, when I plug the values into the formula, it produces a true math statement. So let's see. I've got a leg and a leg here. I know they're legs because of the sides that make up the right angle. So 5 squared plus 12 squared should equal 13 squared because it is the hypotenuse. All right, let's do a little math here. 5 squared, that's not 5 times 2. That's right, Mickey. I know you thought it was 5 times 2. You're wrong! It's fine. It's okay. Don't be mad at him. It's not his fault. He's not brought up on math. He's brought up on cartoon violence. Anyway, 5 squared is 5 times 5, which means it equals 25. Plus 12 squared, 12 times 12, 144, equals 13 squared. Now, you should remember this. Hopefully you do from our time back, or back before winter break, when we had actually a whole lesson, a whole section about our perfect squares. But in case you're struggling to remember what 13 squared is, we can always do a little vertical multiplication. 13 times 13. 3 times 3 is 9. 1 times 3 is 3. 1 times 3 is 3. 1 times 1. Add it together. 169. Add 25 plus 144, we get 169 That does equal 169. That means that this triangle is a right triangle, and we verified it using Pythagorean Theorem. Now, what we're going to look at next is being able to just be given some values for sides of a triangle to determine, is it a right triangle? So, just stay right there, be right back to it. Once again, look, 4 days of making these videos, and for the 4th day in a row, the family is coming to watch the son of the teacher of the universe teaches some algebra. Anthony, Ross, Rebecca, Nelson, Elmo, thanks for being here, guys. I appreciate it.
One eternity later.
All right, we're back, ready for a little more Pythagorean Theorem action for today. The question I've got for you is, if I tell you I've got a triangle, the triangle has side lengths of 6 centimeters, 8 centimeters, and 10 centimeters, will that triangle be a right triangle? We look at also a triangle with 7 feet, 9 feet, 11 feet as the length of sides. Would this triangle be a right triangle? Well, the way to find that out is to use, again, our Pythagorean theorem, which of course is a squared plus b squared equals c squared. Now, even though I'm not given a picture of the triangle here, that's okay. I'm actually okay with that because I know that if I've got the 3 lengths from the triangle, I know the biggest length, in this case, 10 centimeters, has to be the hypotenuse, because the hypotenuse is the largest side of a right triangle. So, using my Pythagorean theorem, that means that I've got A, B, and C, and that's a funky looking B, but we'll leave it there. Don't make fun of my handwriting. It's okay. You'll know it's not great. 6 squared plus 8 squared. And we'll put a little question mark through the equal sign because we're not sure yet. We don't know if they're equal. If they are, then we have a right triangle. If they're not, then we don't have a right triangle. So let's find out. 6 squared is 6 times 6. What's 6, 12, 18, 24, 30, 36. Plus 8 squared is 8 times 8. And 10 squared is 100. 36 plus 64, well, 6 plus 4 is 10. So we go 0, carry my 1. 6 plus 3 is 9, plus 1, that's 10. 100 does equal 100. That means I've got a right triangle. So over here, maybe we'll have the same another right triangle, or maybe this is a counterexample. We'll find out. 7, 9, 11. A, B, and C. Now we just plug them into the formula. 7 squared plus 9 squared equal sign with a question mark equal 11 squared. We don't know if they're equal. We're going to find out. 7 squared is 49. 9 squared, 81. 11 squared is 121. What's 49 plus 81? Yeah, you? Yes, that's it. It's 130. Wait a second. 130 and 121 are not equal. So while this can make a triangle, it does not make a right triangle. All right. That should be good enough for the math side for today. Tomorrow what we're going to look at is finding out a missing side length, a missing leg, or missing hypotenuse from a right triangle. And then towards the end of the week, or the last 2 lessons of the week, we'll do a little review over some things from the first half of the year, first 3 quarters of the year that might need a little help. But again, check these out every day. Just a little thing to help alongside our Edgenuity. Also make sure you're logging into Edgenuity every day, getting some work done. You need to be through 100% of this section by Friday. And Friday's even a holiday, so I'm just saying you might want to get it done by Thursday. If you need help, my remind's available. You always check out the YouTube, things like this. Email me, let me know, so we can make sure you're getting all the stuff done we need to get done. Anything else I'm forgetting? No. Have a great Monday. We'll see y'all later.